This is the review for Tuesday's test. If you're watching the video before you've worked the problem, please pause the video, work the problem on your paper, and then check your answer. This first problem asks us to find the value of x. We want to treat this equation like a balance scale. We have two sides of our equation. We can do anything we want to one side as long as we do the same thing to the other side. So I want to focus on this side that has x on it, and I want to undo any operations that are being done to x to get x by itself, because if x is by itself on the right side, whatever we have on the left side will be the value of x. The only operation being done in this equation is x. We have x and we're subtracting 12. So how do we undo subtraction? What's the inverse operation for subtraction? It's addition. You can find your inverse operations if you remember PEMDAS. Remember, we circled parentheses by itself, exponents, multiplication and division together, and addition and subtraction together. We circled multiplication and division together because they're inverse operations. You can undo multiplication with division, and you can undo division with multiplication. The same goes with addition and subtraction. You can undo addition with subtraction, and you can undo subtraction with addition. If you imagine a number line, and you started at 0 and you added 3, you could undo that operation by subtracting 3. You'd end up back at 0. So that's what I'm going to do with this minus 12. I'm going to undo this subtraction with addition. I'm going to add 12 to the minus 12. But I can't do that unless I do the same thing on the other side. So let's add 12 on the other side as well. This part that I'm circling, minus 12 plus 12, is 0, so it's not there anymore. 0, so it's gone, and all we have left on the right side of the equation is x. On the left side of the equation we have 4 plus 2 is 6, 3 plus 1 is 4, so x equals 46. But we're not done. We want to rewrite our original equation, 34 equals x minus 12, and I want to substitute my value of x into that original equation. 34 equals 46 minus 12. If this is true, then we have the correct value for x. So 46 minus 12. 6 minus 2 is 4. 4 minus 1 is 3. So 34 equals 34. So our value of x checks out, and we can circle our answer or put a box around our answer. Problem 2 says, consider the model below. What equation is being represented by this model? This model shows a balanced scale. The scale is like our equal sign. We have two sides of our equation. On the left side I have x. The cup represents x plus one additional chip. It's positive 1, so plus 1. On the right side of our equation, or our scale, we have 5 chips, value of 5. So x plus 1 equals 5 is the equation. What value of x would make this model true? Well, we can work on the equation or we can work on the model. Let's do both. I can do anything to this side as long as I do the same thing to the other side. So I'm going to undo this addition with subtraction. Minus 1 on both sides. 5 minus 1 is 4. This part goes away because that plus 1 minus 1 is 0, and all I have on this side is x, so x equals 4. We could see that on our model. If we crossed out one chip, took one chip away from the scale, we'd have to take one chip away from the other side, and all we'd have left on the left side is x. On the right side we have a value of 4, so x equals 4. And we're going to check that value of x by plugging it back into our equation. Our equation was x plus 1 equals 5. I'm going to plug 4 into that. X equals 4, so 4 plus 1 should equal 5. And it does. 5 equals 5, so that checks out. Now on the test, if it asks you to check your value of x by plugging it back into your equation, make sure you do that, because part of the points on that problem will be, I'll be looking for that specifically. So just because you can see that it's definitely 4, show this work, or you won't get full credit on those problems. Okay, we'll pick up the review with problem 3 on the next video.